let's talk absolute value inequalities. Like we just said, this is where we end up with our symbols. For greater than and less than. Now, the way that you can set this thing up, if your absolute value is less than, and this is the one that we just graphed from the two equations on the page, it's always going to be between a positive and negative solution to this setup. If the absolute value is greater than it, we actually end up with 2, but what we're saying is those 2 points that we find, it's everything to the outside of it. It's everything bigger than the positive, bigger than the right-hand number, or smaller than the left-hand number. So the steps remain pretty similar. Still got to isolate the absolute value. You got to be careful to switch the direction of the inequalities if you ever divide by a negative. Make sure the absolute value is on the left side, like it is listed up here in these notes, because if it's on the left side, it makes the identifying whether it's going to be the ends left and right or in between those 2 points easier. Rewrite in one of these forms and we can find this expression and we're going to graph it too. And then we solve. So let's do one and we'll work through it. So write this one down. So our first step is still going to be to isolate that absolute value. Now, we can do algebra with an inequality just like we do an equal sign. The only thing we need to remember is if we divide by a negative number, we need to flip its direction. Okay? So we're still going to minus that 5. We get negative 8 x minus 1. And we didn't divide, so it's okay. We just subtracted. That's negative 2. Now we're dividing by a negative. That'll give us this x minus 1. Now, negative over negative is going to be a positive, and 2 over 8 is a fourth, so that's 0.25. But what we need to remember here is because we divided by a negative, we need to change the direction that that opens. So this is the expression we need to work with. Now we still check this the same way we did the other one. Is the number a positive number? Yes, 0.25 is positive. Okay. So at this spot right here, we know we're going to get an answer. It's either, so we've got to go through and figure out which set of inequalities we have. So is our inequality opening towards the number or is it opening towards the absolute value? It's opening towards the absolute value. So what that's going to mean is that when we get our answers, we're going to get 2 answers on our number line. Our shading is going to be everything this way. It's going to be outside. If you ever open towards the absolute value, it's going to shade the outside edges. And the key is we need to figure out these numbers. So we can do x minus 1. See, it says take the stuff inside, set one positive and one negative. Now you got to remember the flip on this, right? So I'm going to tell you a trick. Once you realize which way you're going to shade, you don't need the inequalities anymore. I'm going to solve this problem just like I did the last one. I'm going to make this equal to 0.25. And I'm going to make this one equal to negative 0.25. I give you those notes because that's the exact way that if you look this up, it's going to show you to write these inequalities and deal with them. But once I know, because it's facing the absolute value, that it's going to shade outside of these two numbers, the only part that I need to find now are these two numbers. Because what I hate about this is memorization. If you forget which way these things are supposed to open based on which one's positive and negative, you're gonna miss this problem no matter how well you do it. Okay, if you remember it goes to the outside of these two numbers and we just solve for these two numbers, you're gonna get it right every single time. So we're going to add the 1. So this one is 1.25. And we're going to add the 1, and this one is 0.75. Which number goes first on the number line, 0.75 or 1.25? 0.75. This one down here is 1.25. So we get the idea. It's everything less than 0.75 and everything bigger than 1.25. Now we're not going to include the endpoints because there was no little equal sign here. So if we wanted, we're going to practice writing this in a couple ways. This is one way that you could see this. This is a representation on the number line. We could also see this in interval notation. You guys remember interval notation? That's what we just did last week. So this is negative infinity to 0.75. Remember, your infinities always get a rounded bracket, and since the endpoint's not included, so does that. 1.25 to positive infinity, we put a u between them. That's another way that answer can be expressed because it's a set of numbers. Last one, you could make these things inequalities. We could see them. So x is related to 0.75. Is x smaller than 0.75 or bigger than 0.75? And you look at your shading, is it to the left of it or to the right of it? Our shading's to the left of it, so x is going to be smaller than 0.75. And we're comparing x and 1.25. This is where x is bigger than 1.25. All three of those answers mean the same exact thing. The reason we practice finding all of them, especially when we do our practice, is I don't know which way a particular question may give you the answer. So I want us to understand that they all mean the same thing and they're all valid ways to express this answer, because I'd hate to practice only interval notation. And then you have an answer that you have to choose from that's an inequality and you get confused. So when we do practice some of these, try practice writing all of them and drawing the picture. I always suggest drawing the picture first because I think the picture makes more sense and then you can reason your way to the other parts from there. Let's try another one. So go ahead and write this one down. And I want to see what answer you guys get. So I'm going to give you about 5. Should, right? All right. So I pre-did this to this spot right here. So we've got to isolate that absolute value. So we've got to minus that 9, and then divide the 10. There's no need to flip the inequality because we didn't divide by a negative. So our inequality is still facing the absolute value. So is that going to be to the outside or between them? So let's go back to our notes here. If we're facing the absolute value, this one is going to be to the outside. This one is the one that's going to be in between. And we're facing the number, okay? So we're facing the absolute value. So we're going to find 2 points, 2 numbers, and it's going to be everything before it and after it for our answer sets. So we don't need to worry about that inequality anymore. 8x equals 5. and 8x equals -5. So that means this is 5/8 and -5/8. So which one comes first? -5/8, going left to right on the number line. Do we get to -5/8 or +5/8 first? We get to -5/8. And then +5/8. Now we need to deal with the inequality. It has a little underline under it. That means absolute value is greater than or equal to. Since we get equal to, that means that our points are going to be filled in. They're going to be included this time. So it'll change the way our interval notation looks. So this was -∞ to -5/8, but this time we get a square bracket there because that one's included. 5/8 to +∞. Remember, your infinity is always rounded. But again, we're including that endpoint. It's going to be squared. When you're solving these absolute values, they're either going to be both endpoints going to be included or both endpoints are going to be excluded. It's never a mixture of both. So then this is, we put x and -5/8. We're writing in all three of them. This is where x is less than or equal to, and it's equal to because the point's filled in, 5/8. It's everything to the left of that 5/8. And x and 5/8 here, this is where we shaded above it, so x is bigger than it, but it could also be equal to it. So there's all three of our answer representations.